with an assessment, one of the things we want to do is reconcile any errors or mistakes that students may have had, and then we want to give everybody a second crack at it. We want everybody to have another shot at it. And you may be familiar with how that works, but basically we have a set of quick statistics for the assessment that everybody completed as a whole. And here you'll see that the average score in the class was a 4.49, almost 4.5 out of 5. So if we say that's 4.5 out of 5, total points possible, 5 points, and that's what everybody did. That's basically a 90% average overall for the class. One person scored greater than 100. 2 people scored in the 90s. A fourth person scored in the 80 to 89 range, and then a final student in the class scored 60 to 69. And again, this is the first attempt. So what we want to do is take a deeper look to see where there might have been challenges or issues with the questions. And then we're going to review in brief what to do if you're reconciling. Are there any questions about?
Yeah, Doctor, I have a question.
Go ahead.
Yeah, so you see, when we go to see our grade in our first attempt for like the assessment, I was asking you if we get to see the answers we put,
Yes.
the right and the wrong, because I tried.
Yes.
It doesn't show. You could just, but it doesn't show the test.
Okay.
It does show it.
Well, hold on. So if we go into the test options, let me just check something here, right? So I want to make sure that the test options allow people to see it after the deadline. So the deadline was supposed to be 2 p.m. today. We're supposed to have an hour. It says don't allow students to start the test after the date, and show test results and feedback to students after the date. So that you should be able to get in there. And what you need to do is in my grades, or another way to do this is to go back into the assessment. So if you start to take the assessment again, after a screen or so, you're going to see an option to view previous attempts. And in the lower right corner, there should be a number score with that number score is what you scored on it, except that it's blue, it's linked. And when you click into it, you should see the assessment itself.
I think what it was that we were trying to view it before. I think since it works now, I can.
Yes.
I can look at mines now.
Yes. If you attempted to view it before the deadline, then, and why do we do that? We do that because sometimes students help each other. And I know it's crazy, but hey, well, let's flip a coin. It's your turn to take the assessment first. And now you take screenshots of the questions and the answers. Then you email them to me, and then we'll flip a coin, or it'll be my turn next time, right? And sometimes people do that. So what we do is make sure everybody has a window of opportunity, and then when the window closes, then you can go in and look at your answers. Does that make sense? I hope it makes sense. All right, so what you should see now on your screen, if you click into your score, is something that looks like this, and it should also have, where there were mistakes, red X's. It should show information, and it should also show red marks if there were any mistakes. So what I'd like to do, though, is go back out of here and then do an item analysis of the assessment to see where the weak questions were. And that's what we're going to do now. So we're going to generate an item analysis of our first attempt at Module 1. And we'll run this. And voila. So I'm going to go ahead and print this, just so I have a copy of it. Basically, the outcomes that we received from this assessment are actually pretty good. I've explained in other classes that we don't care much about discrimination because in mastery learning, you quite often have everybody getting a question right. If the question was worth 1/4 of a point and the average score was 1/4 of a point, 0.25, that's 1/4 of a point, then every student answered the same, every student answered correctly, and statistically speaking, the item analysis thinks, oh, this could be a poor question or a fair question, because I'm not picking up on the fact that students are answering differently or they're discriminating between different answers. And that should happen. If you have students that don't understand or don't get something, you're going to have a whole mix of answers. And so what the statistics are trying to generate is this index of, where's the mix of answers? They don't account for a scenario where the intent is to make sure everybody knows a few things and they know them really well. So, but we do want to see cannot calculate, because that means 8 questions were answered correctly. Usually what it means is that 8 answers were answered correctly. Sometimes it means every person in the class got it wrong and they all answered it wrong the same way. And that's not usually the case. That's why we care about the average score. So I'm going to sort by average score, and I'm going to find out which questions didn't have a good result. But this is the part I want to check on. I want to see I have a mix of easy and medium questions. And if there's a hard question or so in there, that's all right. So it's okay to see 1 or 2 hard questions, but we generally want to see an even mix or close to it of easy and medium questions. Are there any questions about what we've shared so far?
No
Okay.
question.
Okay, so I'm going to go ahead and make sure we're seeing all the questions on here. So this is an item that most everyone got correct. It was worth 1/2 point. You had to label the von Neumann diagram, you had to fill in the blanks, and you had to follow along with the study guide, which means you had to use the diagram in the picture, this diagram, and label A should have been RAM, or random access memory. Label B should have been CPU, or central processing unit. Label C, you see the input arrow, that's input. See the arrow going out. Label I would be output. Let's talk about D. This would be arithmetic logic unit, or ALU. E would be data. G would be instructions. So memory always stores data or digital information, and it always stores the instructions that are used to process the digital information. So it's either data or it's instructions. That's it. And that's what's in label G there. Label F here should be registers. So there's a mini register of memory, very fast, very close to the ALU. It's called register or registers. Label H should be controller or control. You could have lost a point if you misspelled it or something like that. Any questions about this? I think most everybody got this one right.
No.
Okay. Yeah, good.
All right. So, but let's look at the questions that were more challenging. So what we're going to do is go down to the bottom of the list, and we're going to define hypervisor. So if we look at our study guide, and we went over this before in the previous trial of the assessment. We said that the definition of the hypervisor is that it shares the physical resources of a host with other systems. That's, in so many words, that's what the study guide says. And you see a number of students, 2 students got that correct, but there were 3 students who answered the alternative answer, which was incorrect. It says, provide host applications to guests as needed. That would mean that something running on the physical machine is usable and visible by one of the virtual machines, and that doesn't happen. The physical machine and the virtual machines or guests can't see each other and they can't interact with each other. Are there any questions about that?
No question.
Okay, so that bogus answer is saying if I have an application running on the hardware down here in component C, I'm sharing that with component A, and that is incorrect. The applications that are running in component C on the physical layer are only seen and used on the physical layer, on the physical machine. Anything that's going on in the guest machines can only be seen in the guest machines. All right. All right, so let's go to the next question. Limited disk space. For virtual systems, what guidance is recommended when a host has limited hard disk space? Choose the option below that reflects the best use of virtual systems with limited resources. And one of the things we called out in one of our assignments is that if you have limited resources, you can install a virtual machine even if you only have 10 gigs of space, right? And basically the rest of the answer choices were bogus. Here's the answer choice that some students selected, and this is an incorrect one. It says use of the cloud will allow the setup of a smaller virtual system if space is an issue. We don't have a cloud in this picture. So when we say cloud, we're talking about OneDrive, Google Drive. We've never talked about using one of those for, you know, a virtual machine. Any questions? Does that clarification help?
Yeah, good.
Okay, let's look at the third from the bottom. What, so far as industry trends come and go in the computer and tech industry, virtualization has developed into a strong and long-term trend. What factor made this trend possible? What factor made virtual machines possible? Well, the biggest factor has to do with Moore's law. We can run a machine in a machine in a machine. You can have a Windows system running inside a Windows system, running inside a Windows system, because the hardware has progressed so far and so fast, it's like a Lamborghini. You can buy it for $0.25, and 1 gallon of gasoline will take you 1,000,000 miles in the Lamborghini. That's the analogy we used in the study guide. Your author in the textbook uses a different explanation, but it's similar. Basically said, you only need one hardware, real hardware, physical hardware machine to run many machines, because hardware has advanced so much. We had 2 students that answered the von Neumann model. And the von Neumann model has nothing to do with what makes virtual machines, or physical machines, or the trend behind virtualization. The von Neumann model is true for physical machines. It is true for virtual machines. Every computer system follows the von Neumann model. And that's why computers exist, period. It's not the reason why virtualization came about. So it is important in terms of understanding how is it we have computers And how were those invented? I mean, how, what are the parts and how do they work? That's von Neumann. Moore's law explains how hardware is so big and so bad and so nasty, it's so good, it's so high performance, we can run machines within machines within machines. Does that explanation help? I hope so. All right, so let's look at the fourth question. How is a type 1 hypervisor different from a type 2 hypervisor? Select the best option from choices below. The correct answer is it is installed over bare metal, which means it's installed directly on top of the physical hardware. If the hardware is made out of metal, it's directly on top of the hardware and is more efficient. That's the correct answer. We had a student that answered, it is installed over the operating system OS to share system resources equally. It doesn't share systems resources equally. The sharing of system resources is very unequal depending on the, now, generically, a hypervisor shares resources, but it doesn't share them equally. And resources are shared between applications. So this is a fuzzy answer, and it could be confused with something else, but that's it. Are there any questions about type 1 and type 2 hypervisors?
No.
Okay. Okay. All right, RAM is like, so one way to understand what RAM, random access memory, does for a computer system is to compare the computer system to a workshop. This is in your study guide, and then we have a sentence that spells it out plainly that says RAM is like the bench, the workbench of a workshop. That's the correct answer. One student selected bins and shelves. That would be the incorrect answer. The bins and shelves are like what other component of a computer? Anyone? I'll give you a hint. You put stuff out to store it, and then you take it back from storage to read it. What part of von Neumann's model does that sound like?
Input and output.
Input output is correct. It's especially the input output of a hard drive. I want you to think of the hard drive as the shelves and bins that store things for later use. That's what a hard drive does. If it stores things for later use, that's persistent memory. That means it persists, it lasts after you power off the computer. Good answer. Okay, moving right along. A virtual caveat. But once we get to this, all right, this is the one we need to look at. And then the rest of the questions look like students got most of them correct because the average score was close to their value, except for maybe this multiple answer question. So we're going to go ahead and look at Gordon Moore's question, and then we'll slide up to here and look at these two questions. Because these two questions were worth a half a point each, and some students got those incorrectly, answered those incorrectly. So Gordon Moore was the computer science pioneer who created the common model of hardware components used for all computer systems. No, that's John von Neumann. Gordon Moore was the one that came up with Moore's law. Every 18 months, the capacity of a CPU doubles. So every 18 months, it's the new CPU that comes out to market 18 months later can do twice as much, twice as fast in half the time. That's what it does. Okay? Any questions? Okay, let's look at VirtualBox distinctions. So in multi-answer questions, if you select an incorrect answer, the points that you would have earned are deducted from any that you got correct. So you can get a 0 on a multiple answer question, even though you did answer one of the choices correctly. Does everybody understand that? Okay, it says VirtualBox is distinctly different from other virtual solutions. Select the answers below that correctly reflect these differences. It is available as a trial that can be converted into a commercial version. Well, that would be more like VMware Player. That's not VirtualBox. It is promoted by Microsoft, who makes virtual solutions for every platform. No, it's not promoted by Microsoft. It's promoted by Oracle. It is available at no cost for a limited trial period, which can be renewed. So this one says you can convert it to a commercial version. You can pay for it. This one says, oh, it's a trial and you can just renew your trial. That's not true. So these other two answers, so it's in a multiple answer question, it's often helpful to try to hone in on the ones you know are false, and then you narrow it down to the ones that are more likely to be true. If I read both of these answers, it can operate on more host systems than any other virtual solution. That is correct. That's stated verbatim in your study guide and in the textbook. It'll run on Windows. It'll run on a Mac. It'll run on Linux machines. It'll run on special Unix machines and mainframes. It uses the host operating system as the hypervisor for guest virtual systems. This is also stated verbatim in the study guide and in the textbook. In most cases, you have hardware, you have an operating system, and then the hypervisor for a type 2 hypervisor runs on top of the operating system as an application. VirtualBox doesn't do this. Instead, VirtualBox uses the operating system as the hypervisor, and that's unique. VirtualBox is unique in that respect compared to all the other virtual type 2 solutions. The hypervisor is just another application. So if you have Calculator open, you're browsing the web, you're looking at your email, you're streaming media in YouTube, and you're running VirtualBox, well, if you're running VMware or you're running Fusions, those are applications like the other apps you're juggling. In this case, part of the operating system is taken up by VirtualBox. So it's more of a dedicated resource. It's cleaner, it crashes less, uses the operating system as the hypervisor. Are there any questions?
No.
Okay.